Hello, everybody. Um, Welcome to this talk. Today, we're going to talk about software architecture and software design. My name is Eddie. I own a computer, and that's a true story. We'll be talking about um, an implementation we worked on in a real project where we could apply some architecture pattern, and it worked. So, we're going to talk about the challenges and all that stuff that we face when we're trying to do something like that. So a little bit more about me. I'm a software developer at CodeMiner for two. um, I have a YouTube channel where you can watch me, if you can listen if you can understand that. um, and but in case you can't, you can um, read what I write in some platforms, different platforms. So yeah, that's me. Let's get started. Um, Today we're going to talk about the state of software design, like how, like what I could find when I was trying to get some examples, um, and we walk through this implementation, and hopefully you will learn the building blocks of software architecture, and you will be able to apply to any any project, you know. And we will do that through web application architecture, and you will understand that. Yeah. Everything starts when I was moved to a new team in this company. I was moved to this new team, and I saw that they were struggling to find a bug, and of course to fix it. It was a simple bug, actually, so it shouldn't be that hard to fix it. The main reasons I can remember, the first one was we didn't have any test, which is really bad. But we also didn't have a clear definition of where the thing should go. We didn't have the clear boundaries, so it was really hard to understand where where what where the issue was. So um, due to that, like this, indeed, that what was happening from time to time. From time to time, the team used to face a bug that was a little bit hard to identify and hard to fix it. So our boss just decided, hey, we need to migrate that, and what we need a single place for that. And we did that because it was a core of our application. We needed some focus, like we need to have focus on that. So we decided to migrate that, and that's how our journey starts. And I was lucky because I was the one responsible for doing that. I started working with one of my teammates, but that guy left the company, and it was just me. The other guys were focused in some other projects, so it was me. And looking at the example, like we had, the existing application, I just um, thought that it would be great to have an architecture pattern. I was reading that book from Robert C. Martin, and I mean, I thought, hey, I can apply that, and I can take this benefits. Um, but the great thing I think I like about architecture is that it defines clear boundaries. So you have a clear definition where things go with all that abstractions. You can understand easily um, which layer interacts with each layer. So you have this definition, and it's great. And because of it, we have a clear definition. We have a cheap change in cost. So I was looking for that because I didn't want, like, we needed a scalable application, of course, like the application itself, but we also needed the team to scale. Like the team should be able to work on it uh, with no big problems. So that what I was looking for. I was looking for that, you know. So I started wondering how I could do that. Um, and I started searching on GitHub. GitHub's a nice platform where you can find a bunch of examples. So I searched for clean architecture, and I found a bunch of examples. And you can do the same for onion architecture. If you look for hexagonal architecture, it will be the same thing. You find a bunch of examples of boilerplates for web APIs. You know, um, and there's no problem with that, because we will see later on that software architecture is about the software, not about web itself. So web is just the requests coming in are just the interface. But I wanted to see some example more related to what I wanted to do, but I couldn't. So I just saw a bunch of examples of REST API boilerplates. And if you look like for more languages, I just filter it by JavaScript and TypeScript because it's the most popular language in the world. But if you expand that, you'll see some examples for C# and Java, also web boilerplates like REST APIs. And you will also find some front-end implementations, really cool, but it was not a front-end. And you will find some Android. But nothing that was close to what I was looking for. Because this application is a little bit unconventional. So it's a little bit different. First of all, it's not a REST API like the majority. So it's different. It deals with background jobs only. The existing application we were about to migrate, it was just background jobs also. So we had it was composed of two projects. We had a project that was handling the jobs, like the job scheduling itself, so cron jobs, some jobs related to Kafka topics. And we had this other project that was responsible for processing that job. So we had two projects just to do that. And even though it's a core of our team that's about fulfillment, just to clarify, my team handles fulfillment. um, even though it's core, it's simple. So this thing was a little bit complex, two projects to handle it. And my boss asked for a single project, so I needed to come up with that. And then I started. I mean, during my research, I also looked into some internal examples. Internally, we call this kind of project task runner because it only deals with jobs. It takes jobs, process them, and talks to external services, and that's it. So that's why we call it task runner. We had an example in our business unit for a task runner, but it was not that great. I couldn't even understand what was going on there, and one of its creators told me that I shouldn't follow like what they were doing, which tells me that they started like with some clear definition, but they just got lost in the process during the when the design should evolve, it couldn't. It just got a mess. So yeah, since I couldn't do that, like I couldn't get an internal example, nothing like that. I just um, I just looked in the examples I had that as I mentioned, a bunch of REST API boilerplates. So I just started wondering how I could translate that. You see that it could be simpler than I did, but that's why this talk exists. A coming application, it's coming like you have a controller for handling HTTP requests. You have some services like some classes, some modules that will help you to work on your business logic, and it will produce a result. I don't know. It can be persistent to a database, calling an external provider. For example, in our application, we need to call an external service for the one of our party that really manufacture our products. So yeah, like in the common application, it's like that, and it's very common. I mean, when we start an application in a REST API, that's what you do. Um, you have a controller. Let's talk about, for example, Rails. You have a controller. You'll be creating some classes and for services, and that's how we will do it. It's kind of automatic, and so it's easy to translate that into a more well-defined architecture, because I'm not saying that Rails has some architecture like not like I'm going to show here. It has some MVC pattern or something like that. But how it differs from the application, how the common web application differs from what I was trying to do. First of all, again, obviously, like my application had to deal with queues, jobs, and workers. So there's no this concept um, of a controller like you see, applications and stuff like that. And I think that's the part that got me in trouble. I got in trouble with that because I had to come up with a single application. So since it deals with queues and jobs, it kind of calls itself, you know. So I had to come up with something that works. So I got in trouble. That's the truth. Um, I think that there are two ways you can apply an architecture pattern to any project, and the two options, I can think of two options actually. The first one is you master it. You master the architectural principles. But if the stock exists, it means that I didn't master at that time. I studied architecture, was reading about that. I was seeing I had seen some examples, even wrote some code, some type projects, but it's not the same, when you need to produce something that really goes to production. It's a little bit different. So what did I do now? What you can do in this case? You can make some analogies, and that's it. I mean, you can get what you have and try to translate into what you want. And then when you do that, you will end up mastering it. So you won't need to make kind of some analogies anymore, only when needed, you know? So let's walk through a web application architecture. I was talking about web application architecture, but you know, in fact, it should be the same for any software, because that's what architecture is about. Like, we apply pattern to the software. There's no It's not tied to any tool or any concept like that. Like, we will see that. Let's go. So if you think of a higher level visualization, that's basically how your application will work. You will have your application handling, I don't know, endpoints, REST endpoints, and then a request comes in, and you do some logic with it, and then you have some outcome. And this outcome can be anything, like I mentioned. It can be database persistency. It can be an external service that you call. And if you think about it, it's more like, um, uh, if you generalize that, you can see that almost like you do when you are starting to write code. Like, you have the inputs, and you have your algorithm, and then you have some result. So it's similar. Um, and the first definition we can see, like, it's about driving. We have what drives our application, and we have what's driven by our application. So in this example, an HTTP request drives our application. It starts the interaction. So the intent comes from the HTTP request, and the application handles it and then drives a database, for example. You know, so these are quite clear boundaries. Like, um, we, if you think a little bit about it, you definitely want to have these things separated. You want to have your application isolated from what drives and what's driven by, because you want to change stuff. So let's say you have a JavaScript application, web application, you have Express.js in front of it, taking requests, and then you do something with those requests, and you're using I don't know, MongoDB for storing your data. But then you just decided, hey, Fastify looks great. I want to try it. I don't know, it's faster. It should be faster, huh? It's Fastify. And then you want to change it. You should be able to change it without touching the application. The same for database. You should be able to change MongoDB without touching the 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 application. So you want to isolate that, because in the applications is in the application lies what's important for your business. Once a person asked Alistair Coburn, like, you defined what drives application and what's driven by, like how we can handle it. You define that, but what do you say about what's inside the application? And he just said, I don't care. And yeah, that's cool. He doesn't care about what's in the application. It's up to you. But the point is, it should be isolated. So it's a great principle to start. Uh, but if we look closer into the application, we will see that it will be something like that in all these architecture patterns, because they come from the same thing. They come from the same principles, you know. So let's see. We have an HTTP request coming in. We will have a controller handling that, talking to a use case, and by use case I mean feature. So uh, we wanted to have a feature that was create an order in our party, in our partner, actually, sorry, in our partner. So we would have a use case calling create order. So it would take this information from the request. In this case, it will get some entity from domain maybe, and domain is the very most important part of your application, because in domain is where the business logic lies. So in this case, the features takes domain, where the business logic lies, and some service contracts. And that's a great thing, because the use case should know only contracts, because the use case should not care about the concrete implementations. So let's say we create an order and send an email or something like that. Actually, for creating the order, we have a domain for doing some validations, and you have a service that talks to this partner's API. So it just says create order. It takes an input, and the use case only knows that there will be a create order method or function, and to call it, and that's it. The concrete implementation will be passed later on. So we have these things decoupled. Um, so it's easy to understand and even to test. Of course, you have to know a little bit of design principles before. Like, I mean, how objects, the object relationship, you know. So that's simple. I mean, you will see a bunch of examples doing that in some different ways, but the same, you know. But I could not see something. I knew that I wanted to have this contract implementations. Like, I knew that I wanted to have use cases, because they're great. I like how when we have use cases like that, you look at the application and you know what it deals with. Like, it screams, hey, I deal, like, for example, this fulfillment, I deal with shipments, fulfillment, product delivering. um, so I like this. So I wanted to have that. And I also wanted to have these contracts, because I started thinking of, like, how we could test it, like how could I make it easy to test, so the dependency inversion was great. So I just ended up doing that. So I knew that, look, but I was with some questions, like, related to interaction, like, how could I handle jobs? Where should I put that? And what's the place of the worker? You know, and the harder for me, how can I have cron jobs on it? Because this application needed this cron job. So I was with these questions, and then I started talking to some teammates, like very experienced teammates I have. So he just said, "Hey, let's think about it." So we just came up with some analogies. I just realized that an HTTP request is like that. It comes from outside the application, and it might carry some data, some payload. And the HTTP controller, it will handle the incoming request, and it will transform incoming data into a general structure that is passed to the use case. Okay, so I knew that since my questions were in what drives my application. I just started thinking about it. Okay, what's my case? So I started thinking, and I just realized that, in fact, a job is the same thing. It comes from outside of the application, and when I say the application, I'm talking about that that one in the middle, that layer. Let's talk like that. And it also can carry a payload. Okay, the job data is a payload, and a worker handles incoming requests. That's job, so it handles jobs. And what it does is it just delegate to use case, the same as a controller. So I just realized that, and that was amazing. So we ended up with something like that. Um, we were using BoMQ. That's a nice library for background jobs. Um, and it's an important thing. I haven't mentioned any tool so far, and that's great because architecture is about separating what matters from the details. So BoMQ, for example, is a detail. We don't care about BoMQ actually. If you need to change it, we'll change it, and that's it. You know. So what's happening is that BoMQ includes a job, and we have a controller that's a worker that will be listening to a specific queue. And if you can make it one more analogy, that is, each queue is like an endpoint, an HTTP path, and then we produce a request module that will be consumed by the use case. So, like, that's a great thing to have, because with this request model, we can have anything in front of it, you know, and then the rest is the same. So the remaining is the same. That's something I knew already. I knew how to do. I knew what I was looking for. So my questions were in front of it. If you were separating layers, my questions were more about interface, how I could handle it, like this interface with background jobs. The rest really close to what's used. Um, I'm calling this application. You can find some more divisions here, like people say the application and domain. But I'm saying application, what matters, and of course the domain is the most important thing. So yeah, I was done with that. I knew how to handle this interface, but I was still in trouble because I needed that cron job working. And the point is, I I could not create a new application like we had two applications, one calling it. So I think that's the part that I got in trouble, because I I didn't know that. Like, I mean, it does not come from outside, because when we study software architecture, you learn that, hey, you should separate, you should isolate your application, as I showed you. But the point is, the interface usually comes from outside. So think about an HTTP request. It comes from outside. So any other application, any other service, we call it. And think about a CLI, for example. The CLI, we call it. You have an interface, a class. Let's say you have a class that handles the standard input. You take the input and it passes to use case. But it comes from outside. In this case, it's a self-triggered, so it comes from inside. It calls itself. It's a little bit different, you know. And I mean, for example, in the task runner we already had in the team that's working yet. Um, we didn't have this kind of thing, the self triggering. We just had some requests, HTTP requests, and sometimes some some kind of messages that come in, and then they trigger a boolmq job. So it's a little bit different. They also use boolmq, so a little bit different. So I got that. So when I start thinking about it, I can do, like, it's inside of the application, and I knew that boolmq had this capability. So I just started thinking where to put that, because I knew, like, we had that definition that were great, but now I need to evolve that. I need to put more things, and I didn't know where. So, and here's my tip, like what I learned from that. When I found myself thinking about a new component for the architecture, knowing the layers and boundaries, I just asked myself and some teammates, does it fit this layer? I mean, explain it and think about it. Does it fit this layer? And you'll probably get an answer. It's a kind of rubber ducking, but for defining where to put things. So since we were about to use a boolmq capability, and it seems something really concrete, it's a concrete thing. Uh, it seems to fit the infrastructure layer, and I can agree with that. But at the same time, it should initialize with the queues and the boolmq itself. And one more analogy, it would be like what do you do with a web server with sockets. So it should bootstraps. So we ended up adding this, like, it's not adding because it's not something new. Every single application you find, you have something like that, some main module, main layer, you can call it, maybe, I don't know, that will start things. So we just ended up doing something like that. So in the boot, we have, of course, it's a simplification, but we have this service that something I didn't mention, also Redis. We also use Redis for that, but just tool. uh, so we just start the cron job here in the main. So what it does is it starts and it keeps in queuing jobs to a specific queue, and then the rest is the same. It comes to the interface and the application works as expected. You know, and the great thing is that the design keeps evolving. More people worked on that, and I I I saw that people could work on the project with no trouble. Like, they could work on that, understand where things should go, and I'm really happy that it happened. I just got some new things in the project that made it better. So that's something I like in the architecture. For example, that's a high level we have. That's very, very simple, and the simplicity uh, beats the complexity, of course. So that's what we have. The main is where things start, and then we have the workers. We In the folder we called it workers because people were confusing the interface, but and you have the infrastructure. That's a concrete thing, and every single person that worked on that knew, even the less experienced, knew where to put things, knew how things should work, and that's amazing. That's something I like on architecture, and that's my these are my advices for you if you are trying to apply some architecture. If you don't master it yet, you can just go and make some analogies and get it working. Um, so that's it for today. Hope you enjoyed it, and if you have any questions, leave in the comments, hit the subscribe button, and see you